So I hope that it is not noisy, right? So during this lecture, I would like to also know some feedbacks from you as well. So if I ask you some questions, please don't hesitate to answer, because so as a rule, after every lecture or after every week, we have a discussion within our team of professors, tutors, and we discuss how we can improve your experience of getting this lecture. So that is why it is really important for us to get some feedbacks from you. So today we're going to talk about the sets of numbers and also about some operations within numbers like addition, multiplication, and quotient rule. So and in general, I would call the operations with numbers, equations, and inequalities as one branch of mathematics, which is called the algebra. And you probably know that the word algebra is very much connected with the Asian mathematician Al-Khwarizmi. So actually, the word algorithm is taken from his name, from his surname, probably. And it appears even the word algebra is taken from his book, which is called like Al-Jabr wa Al-Muqabala. So it's like they just translated this to Latin, and it became algebra. The word algebra became as in algebra. So I would like to talk with you about sets of numbers. So you probably know what is the set of natural numbers. Can you help me? What is the set of natural numbers?
Natural numbers is the numbers we use them, which we use for count.
For counting, right?
Yeah.
So 1, 2, 3, 4, 5. Oh, do you know whether 0 is a natural number?
No.
Yes, I think.
Oh, okay. So some books shows this as natural number, but I would say that the 0 is not. So when I used to be in the 3rd year in the school, my math teacher told me that 0 is not a natural number. So I remember this from her. So I would also suggest you to do not include the 0 as a natural number. So you need to start counting from 1. It's difficult to explain this to programmers because you usually should count from 0, especially when you're going to write a code in C++. But let's say we're going to start counting in Precalculus from 1, okay? 1, 2, 3, 4, and so on. And this is going to be the set of natural numbers. It is really important for us to get to use from the notation of the natural numbers. We're going to denote the set of all of the natural numbers with this beautiful letter. So whenever you write down the n, you need to put the 2 columns here, okay? So this is going to differentiate this is going to mean that you're defining the set. So we're going to come back to the concept of the sets, which are really beautiful and interesting. But for now, it is going to be simply, we're going to go through this very quickly. So the set is just a collection of bunch of items. For example, the set of natural numbers, you are just collecting in one box lots of numbers, which you can count. For example, we cannot count 1.5, so that is why it is not going to be a natural number, right? So, okay. So there used to be a Leonard Knoecker. So he's also a famous mathematician. So what I like actually in my lectures, I would like to give you some historical perspectives and historical stories about the concepts which we are going to learn overall this course. For example, when we are going to learn about the Gaussian method to solve the system of linear equations, I will tell you an interesting story how this method was invented, in which context it was invented. So I will try to give you some historical perspectives, not so you should learn the years or the mathematicians, or but just like give you some impression how all of these things has been invented, in which environment, in which constraints, okay? So we've defined the set of natural numbers in this way. You're going to always denote the set with the curly brackets. You're going to write down the curly bracket here, the curly bracket here, open it and close this. And you're going to write down the items of your set by just putting the commas. So there are two more important concepts about the sets, like Venn diagram, for example. We're going to come back to this later on. So another set of numbers which are really important are simply the negative numbers and the zeros. So natural numbers are the countable numbers. We're going to start counting from 1 until infinity, actually. And the negative numbers are simply going to in the infinite, minus infinite direction, right? So I will show you later on all of these numbers in the number line. So it's going to be -1, -2, -3, -4, and so on. And all together with natural numbers, with negative integers and 0, it is going to make one set, which we are going to call as the set of whole numbers, or in English, I would just call this as integers. Okay, integer. I think integer is one of the most important numbers for you as a programmist as well. But I mean, the number sets are important for you because whenever you write down a code, especially in C++, you need to define, first of all, the type of your variables, right? I hope that you know what I mean, right?
Right.
If you feel that my English is too fast, is there any option in YouTube to slow down?
Understanding you.
Okay, you understand me?
Your
Okay.
English so good.
Yeah, yeah.
Okay, so if you have any problems with if I'm too fast, so just not hesitate to stop me. Okay, I will try to speak slower, or you can just make your internet connection bad so that my voice is going to be slow. So we are going to denote the integers, the set of whole numbers, which is going to include all of the integers, all of the natural numbers. So 1, 2, 3, 4, and so on, all of the negative numbers, and 0. And we are going to denote this as Z, not just I, so as you might thought. So the Z, this word is coming from the German word, which is Zahl. Zahl, it's like the number, which means number or digit. So we are going to put this Z. Are you taking some notes? As a rule, I would really suggest you to take some notes during the lectures, okay? So it doesn't mean that you need to copy everything, but you see, so I've got the slides and I usually write down something on the top of the slides. And of course, if you need the slides during the lectures, we will try to provide them before the lecture so that if you have tab, for example, you can type on the top of the slides as well. But during the lectures, you need to take some notes because I usually write something on the top of the lectures, something on the notes, and it is always better to get the notes. Again, so this is the set, so that is why I'm going to denote this again with 2 columns on the set. It is going to be the set of whole numbers, the integers. So you can see here which kind of numbers it includes. Okay. Oh, by the way, did you know that German was the official scientific language before the First World War? And all of the books, especially in mathematics and in computer science, have been written only in German. So that is why. So as you go, for example, in our courses, like especially in linear algebra, for example, you will see that many concepts or many words, many definitions are called in German. Okay. Oh, by the way, so do you know that nowadays this electrical automatic vehicles are so much popular and famous, right? I've been Germany before pandemic, and I've discussed with my colleagues about how these things are working in Germany, and I was really surprised to see some of the books and some of the newspapers where it was stated that automatic vehicles have been tested in Germany in 1970s. In Autobahns, they've tested the automatic vehicles in Germany. And it is really difficult and going really slowly nowadays in Germany because of all of this bureaucratic regulations. I mean, so if you think that our country, Uzbekistan, is bureaucratic, just go to Germany. So you're going to see that it is so much bureaucratic. Okay. So now we're stepping into an even bigger set. You see, so we started with a smaller set, right? So do you see that which set is bigger? Integers, natural numbers, or negative integers?
Bigger?
Yeah, bigger. Not
Rational number.
bigger. Irrational numbers?
Natural numbers.
Bigger.
Because it's infinite.
Yeah.
Because it contains infinite numbers, right? But negative integers also contains infinite numbers.
Very cool, I think.
They're equal. Okay. So what about integers?
Yes, integers.
What about rational numbers? Okay, rational numbers is any ratio when you're going to write this down as m over n when both of the numbers are going to be integers. Okay, so we can't really just say that, for example, the size of the integer numbers and the size of the natural numbers are the same as the size of the negative numbers, because I mean there are some tools of measuring infinite sets. We are going to learn this later on, but so far you should just know that you cannot really compare two infinite sets. I mean, you cannot just say that one is bigger than the other, but what we can do is we can say about subsets. Okay, so if you've got, for example, the set of natural numbers, right? Do you remember how we denote this? Like this, and we've got the negative integers and 0. Okay, so both, if you combine, so you need to understand this as the back, as a cup. Okay, so you've got two backs. One contains infinitely many numbers, they're all natural numbers. One contains the negative numbers, and if you just like put them together into a third back, you're going to make the integer. Okay, and actually a set of rational numbers are even bigger than integers because it contains even more numbers, right? So could you please, okay, so let's define what is the set of rational numbers. So the set of rational numbers are not just the integers, they are the fractions, kasr. Okay, so they are the fractions when we are going to write down two integers as in the fraction way. So m divided to the n, where m, so do you know this notation? So you're going to denote this when you write like this. It means contains, or it's inside. From or inside. Okay, so m is from z. What do you remember? What is a z? What is a z?
Integers.
Set of integers. What is the n?
Natural numbers.
Nature.
Oh,
Hmm?
Is there any mistake here?
No.
So, and this.
Okay. Why we should put two different constraints on the m and n? Why we can't just write this as a z? Or we can?
Because it's
Because that
impossible to divide by 0.
Okay, but n can be still negative, right? Yes. So
I
it
think
means that
n is
Yeah.
just
n
the
is the
positive.
rational number.
Excuse me?
If I
No. We've just learned this. You probably missed that part of the lecture. N is the set of natural numbers.
yes,
They're countable numbers, but both of the sets, both of the definitions are wrong because it should be z, and you need to write this except 0. Okay, I think it is going to be the better way. So the n is going to be from the z except 0, because n can be also negative, right? For example, if I write as 3 divided to the -2, it is also a rational number. Okay, so but if you just restrict the n to be from the natural numbers, then it can't be a rational number, which is wrong. Okay, so the proper notation for the rational numbers, it is going to be m is from the z, n is from the z, but n cannot be 0. Okay, so the rational numbers are going to be even bigger set, or not even big. Obviously it is bigger, right? Because it contains more numbers than integers. The integers, for example, 3 and 2, but 3 over 2 is going to be not integer, but still it's going to be a rational number. Okay. And again, we are going to denote the set of rational numbers with some Greek letter, with some Latin letter, sorry. And we're going to put, again, the column here. Okay. So whenever you put the column in your notation, so later on, after a couple of weeks, you're going to be provided with the homework exercises, and you need to write down all of your solutions. And whenever you put the column, the second column, inside your Latin letter, it means that you're denoting the set. Okay, so we need this in order to understand each other. So the Q bar is going to mean the irrational numbers. It is coming from the Italian word quotient. Okay, so okay, so Q is the set of rational numbers. So let's do a couple of exercises on natural numbers. On rational numbers, sorry. So 1.5, is it a rational number?
Yes. Yes.
Yeah,
Because I can write
Yes.
this as a ratio, right? How I
Yes.
can do this? 3/2, right? Or 2.25, is it a rational number?
Sure.
Yes.
Because
Yes.
I can write this as
5.
5/2, right? What about 1/3? Oh, it's also a rational number. It is. It is a rational
0.33.
number. Yeah, 0.33333 and so
No,
on. And I
this
can,
is not rational.
it is rational. I mean, it fulfills all of the conditions, right? Rational is the ratio of the two integers. 1 is integer, 3 is integer. I can do this. So 0.333. You might be confused that this number is going on infinite, like until infinity, unless like this 2. But still, the constraint for the rational number is that unless you can write down this number as the ratio, then this is the rational number. Okay. Now I will show you a number which you cannot write as a rational. So for example, square root of 2. Okay. We cannot express square root of 2 as the rational number, as the ratio of the two numbers.
Equal
Okay?
1 point.
Yeah, so it's going to be 1.41, 42, and so on. So
Blah, blah.
lots of numbers, right? And most of them are not going to be repeated. Yes, Asabi?
Okay.
There is a mistake.
Where?
This one. This should be 9 divided 4.
2.25?
Yes.
Isn't it 10 divided to the 4?
No, 9 divided to 4.
9
Okay.
divided 4.
Okay. Okay, cool. Thank you. Okay, so do you feel the difference between this number and this number? So in one case, I mean, both of them seems very, very similar, right? Because they go until infinity. But so here the 3 is, so they are repeating. Until some point, they start repeating. And again, the constraint is we are able to write this as a ratio. Well, here for the square root of 2, we're not. Okay, so this is not rational number. Not rational number. Okay, so we have a special name for this kind of numbers. We are going to call them as irrational number. And the condition is that so any number which cannot be a rational number is irrational number. Okay, so if you cannot write down the number in a form of a ratio of the two numbers, we're going to call this as an irrational number. And the characteristics of these numbers are that, like, so whenever you are going to write down this as a floating number, when I say the floating, it has a dot, right? The numbers are going to go until infinity, and they're not repeated. As for example, in the case of like 1.3333, or like a 0.3333, and so on. Okay, so here are the rational numbers. So let's do one more exercise. 1.75, is it a rational number or not?
Irrational number.
How you can write
Irrational
it?
number.
How do you know this?
Rational.
It's a 7/4.
7/4, right? Okay, because we are able to write this as a ratio of the two integers. 0.001.
Irrational.
Because we can write this as
1
1 to 100.
1,000, right?
1000.
Okay. So square root of 2?
Irrational.
Irrational. Because we cannot write this, right, as a
It's not so-
ratio.
yeah.
It is 1.42, 41, and so on. So I would like to show you a couple of more irrational numbers. Don't you find irrational numbers beautiful? No? Like, I really like irrational numbers. Do you know why? Because they are so much useful in engineering, like pi, e, or psi, or square root of 2 are used in engineering, in constructions, and you're going to see this overall our course. So do you know why pi is important?
No.
You know what is pi?
Yes.
What is a pi?
When we're solving these problems about circle, we will use it.
Yeah, okay. So
Ratio of circumference of a circle diameter.
okay. So if you take the circumference of a circle, I hope that you understand what is circumference, right? Circumference is how to say this? It's the length of a circle, right?
Yeah.
Okay, so let me denote this as L, and this is going to be the D. Somehow my pen is not working. So the L divided to the D. Okay, L divided to the D is always pi for any type of a circle, right? So if you need to calculate the circumference of a circle, for example, or if you need to calculate the diameter, if you need to calculate the area, sector, whatever, you're going to always need the pi. And the pi was important. So any engineering problem or any problem which involves the circle uses the pi. And it is important for us to know the pi with the really high precision, with lots of digits, maybe hundreds of thousand digits, because we are going to, nowadays, we are like sending lots of spaceships into the space, and doing all of these calculations in the space is really important, because just one digit in the hundredth position is going to change the trajectory of your spaceship dramatically. So calculating the pi with the high precision is very important. E is also important. You're going to see why it is important. So we're going to see how we can say why the E is exactly 2.71 and so on. And there is one more number you probably not know before. Is it psi? It is sometimes called as the golden ratio. Have you know about this number, golden ratio or psi? Probably no, right? So
No.
have you ever heard about something which is called the Fibonacci numbers?
No.
Yes.
No.
Yeah, so I think at some point in programming, you're going to learn about Fibonacci numbers, and then you need to write a code which finds the sequence of Fibonacci numbers. So once you learn this, please let me know, because then I will show you a small trick. Okay?
Great.
How to improve your algorithm, how to cheat your
Okay.
professor. Okay? Okay, so
May I ask a question?
sure.
Why pi is irrational? Because it should be rational because it's the ratio of two numbers, L and D.
Yeah, how it is, like 20/7, right? Or 22/7?
Yeah, it's approximation.
Yeah, 22/7, it's approximation, but it is not exact. It is not the same. So at some point they're going to start. So so I made a lot of research about the pi, by the way. So interestingly, people who used to live in Central Asia, especially in the madrasas of Ulugh work on calculations of the pi. I mean, you know who's Ulugh, right? He used to be astronomer, and it was important for him to calculate the distances and the orbits of the stars, and a really, really good precision. So that is why at his era, at his madrasa, at his university, there was a huge group of some Iranian mathematicians who used to work on the pi. So later on, I will tape a small video with animations, and I will share you why the pi is irrational and why pi is important. Okay, so far you just need to know that pi cannot be written as the ratio of the two numbers. Okay, but here the constraint, okay, Daniel Bey, here is the constraint that this L can be real number as well. You know what I mean? For example, the diameter of your circle is not restricted to be integers always. You know what I mean? So the rational number, for example, 3.5 divided to the 1.2 is not a rational number. Okay, it is not in the Q, right? Isn't it?
But we can multiply to some number.
Okay, but for example, square root of 2 over 3. Is it the rational number? Not any fraction is rational number, right? The fraction of the two integers is a rational number. And whenever you're going to write down the pi as a definition of the pi like this, like the ratio of any circumference of a circle to the diameter is equal to the pi, we can't really restrict L and D are going to be from the set of integers. So because they can be like any other type of the numbers. Okay, so here's the trick. I think I've got your answer question, and I think the answer makes sense, right?
Yes, it's clear.
Okay, fair enough. So the combination of the two sets of the numbers, like rational numbers plus the irrational numbers, or we usually call this in the SAS notation like union, are going to be real numbers. So especially you can understand, you can remember that any number is a real number. Okay, so let us sketch this again. So we've got the natural numbers, right? Do you remember this? And then we've got the set of integers. Do you remember how we denote the set of integers? Z?
Z.
Okay. Which number contains is in the integers, which is not in the natural numbers?
0.
Okay. 0 or -3, right? Okay. Then the next one is
Rational number.
rational. Do you remember? Do we denote this as R?
No.
No, Q, right?
Q, yeah.
Quazione. So it's come from the Italian word, right? Why is that? Zahl, right? Coming from German word. Okay, which number is in the set of rational numbers, which is not in the set of integers? 2 or 3, for example, right? Okay, and the next one is going to be the real numbers. Okay, and any number, so all of the rational numbers plus the set of all of the irrational numbers are going to be in R, in the set of real numbers. So there is even a bigger set. We're going to learn this later on. So could you please tell me again an example? Which number is in the set of real numbers, which is not in the set of rational numbers? Square root of 2, for example, right? Square root of 2 is not a rational number, but this is still a real number. Okay, so broadly speaking, any number is the real number. So there is even a bigger set, which is going to be called as the complex numbers. The complex numbers, as you remember, is the number which contains two parts, right? So one is like the real part and one is the imaginary part. And the main concept of the complex numbers is this square root of -1. So the people wanted to get the square root from the negative numbers as well. So that's why they've introduced something which is called the complex numbers. So I think in the beginning, it is difficult for you to explain the real meaning of the complex numbers. But I hope that overall the courses, we're going to learn about some applications of the complex numbers. Do you know any application of complex numbers? Or do you know why we need complex numbers? Okay, so complex numbers is, for example, maybe 2i plus 3, where I is square root of -1. You probably have heard about the complex numbers, right? So we'll
Yes, no.
yes. Any question? No. Do you know any application of complex numbers? Why do you think we need complex numbers? No? Okay. Have you heard about like Fourier series?
No.
No.
Have you heard about Shazam?
Yes.
Yeah.
Yes.
Okay, Shazam
Yeah, of
works
course.
using something which is called a Fourier series, where actually this is an application. If you look to the algorithm, what it does is it decomposes the sound into the series, into so-called Fourier series. We're going to talk about this more in details, okay? Probably we're going to write down a small code as well, some of your courses. And the main concept of the Fourier series are the complex numbers. So you, at this stage, you just need to know that complex numbers are needed to write down a sound into your computer. This is why, for example, we would need complex numbers, but there are lots of other applications of the complex numbers. But this is the most like famous one and the easy to remember one. Okay, we will do this like in a computer. Okay, so let's do a couple of more like exercises. So if A and B and C are integers and C is equal to the A times the B, then A and B are going to be called as the factors or divisors of the C. So factorization is one of the important topics in precalculus, in algebra, and you're going to see this especially in linear algebra when you're going to factorize the matrices, like so many factorization algorithms. Do you know why linear algebra is important for you? It's the most important subject actually for you because like it's important in the software engineering nowadays. Because you need to work with the data, store the data, transmit the data, work with the data, reduce the data, make the analysis of the data, and all of the things are done so much easily with the matrices and the vectors. So probably you're going to start writing some codes in C++ after a couple of weeks, and you're going to see that one of the important concepts of the C++ are the arrays and the vectors, which is the main concept of linear algebra as well. And another thing is linear algebra is very useful in robotics, for example, as well, because, for example, if you've got the robot and if you would like to move its hands, of course, you're not going to explain this using just like coordinates of all of the points in your robot. Instead, you're going to just write down the matrix. So the multiplication of the matrix to your robot, the hand of the robot, is going to just linearly transform the hand of the robot. Okay, so I would really suggest you to learn linear algebra. You will remember my words after some time. Okay, so it's really important. So for example, 6 can be written in a different form. For example, 6 can be written as a 2 times 3, and I'm going to call the 2 and 3 as the factors of 3. -2 and -3 also the factors of 6, not 3, 6, right? And so on. So could you please tell me how I can write down, for example, 8?
4 output.
4
8 times
multiplied
4.
to the 2.
4 times 2.
8 times 4. Okay, 4 times 2. Okay. 8 times what?
One.
No. It's
1. 1.
Why? Okay.
-2 and multiple for -4.
Okay. What else?
-8.
-1.
-8.
Okay, minus 8 to the minus 1. Obvious one. One more.
Mm,
Huh? Değil mi? To 8. One more. No, no, no. There is one more. Two.
Times 4.
No, two.
Yeah,
Right?
two.
Okay. 2, 2, 2. Yeah. And actually, this is the most important one. Okay. So 12 can be written as a 3 times the 4 or like a 3 times the 2 by 2. Okay.
yes.
11.
11
multiple
1 times 2, 11.
Yes.
That's it, right? So 12 times the 1. 7.
7 times 1.
to 1.
Okay. So there are 5 numbers. 1, 2, 3, 4, 5. And 2 of them are special. 2 of them are different from others. Could you please tell me which one are different?
11 and 7.
11 and 7, yeah.
7.
They are different from the others. Why?
Because, how to say,
They
they
have
divide only to 11 and only to
in
1.
1.
Okay. Do you remember how we call them?
Simple,
Simple.
simple numbers.
Okay. Yes. Okay. So in Russian, I think it is called simple, but in English we call this as prime numbers. Primes.
Prime numbers?
Yes, prime.
Thanks.
Prime number. Okay. The prime number, it's a number which can be written which can be divided to only itself. Okay, it doesn't have factors. Okay, and any number, any integer, or let's say any natural number, can be written as if can be factorized into the prime numbers. Any. Okay, for example, just give me any number like a 256, right? It can be written as a prime numbers, like 3 times 2 times many times, like 8 times 2, right? So any number can be written as the multiplication of the prime numbers. The prime number is the number which can be divided only to itself. Okay, there are a couple of prime numbers, prime factorization algorithm. I thought I have the. Okay, sorry. I thought I have a slide with the prime numbers, but I missed that. Okay, so I think we're going to finish. We finished the lecture now. Do you know why prime numbers are important? Rastli çisla, or in Uzbek we call this tup sanla.
Yes.
Yeah, so you know. Do you know that prime numbers are the most beautiful numbers as well? Why? Because they are so much useful in engineering, right? Okay, so have you thought about why prime numbers are important?
No.
No.
Okay, at some point in your programming course, you're going to write a code which factorizes the numbers into the prime factors. Okay, so you'll be given as an input some number, and then you need to give all of its prime factors. Okay, once you learn this task in programming, just ask this question in the Precalculus, and I will give you a small trick. Okay.
Okay.
Cool. Nice. So let's finish for today. Thank you very much for your attention. You're going to have a tutorial and some homework.
Teacher?
Yes, a professor. You need to always
A
call
professor.
any instructor in the university should be called as professor. Any.
Professor. Okay.
Okay, thank you very much.